Yo, this is Nick. Welcome to a look in the lab, where we discuss the hows and whys of various powder coating test methods. Today we'll talk about ASTM D-4242 Inclined Plate Flow Test. Let's take a look. Inclined plate flow, also called pill flow, or as I'll refer to it for the rest of this segment, pellet flow, is a comparative evaluation of multiple coatings, not a specific intrinsic property of a single coating, and I'll explain why. But first, let's describe how the test works and what it's for. A pellet flow test gives an indication of the degree of melt flow that occurs during the curing of a powder coating and is a great way to determine a couple of important things. For starters, if you are comparing different batches of the same coating during the same test, especially if you have run this test on a batch previously, you can determine if the batches are in or out of specification. A large variance in the results of two powders, which are expected to be the same, quickly indicates that something about the powders are different and should be investigated further. Another application of a pellet flow test is to compare a series of different coatings to assist with formulating or choosing a coating that best fits your needs by observing the differences in the test results. But first, let's talk about how to run the test. A pellet press conforming to the ASTM standard is used to form an amount of powder into a solid cylindrical pellet of a standard size. The test method suggests the amount of powder be 1/2 in grams of the powder's density or specific gravity. In our lab, we typically use 1 gram of powder, although in some comparisons it does make sense to use different weights for the pellets that are calculated to give them equal volume rather than equal weight. The pellet is affixed to a glass or smooth steel plate through heating the plate such that the underside of the pellet only just begins to melt and adhere to the plate. At this point, the plate is attached to a holder that allows it to stand at 65 degrees from horizontal, and the whole assembly is then placed into an oven at the cure temperature of the coating for long enough to fully cure the powder. As the pellets heat in the oven, they will begin to melt and subsequently flow down the inclined plane as the mass of powder begins to behave as a viscous liquid. As the thermosetting cure reaction takes place, viscosity rises until the flowed powder fully cures and becomes solid again. If the flowed pellets were different batches of the same material, and especially if they were compared to a control which is known to be a good sample, you should expect the length of the flows to be very similar. If they are not, this could indicate a potential issue with one or more of the samples. On the other hand, if you're comparing a series of different powders, say for example you're trying to choose a new filler or extender pigment and have incorporated a half dozen different types into the same base formulation, differences in the results can give insight into which filler is best for your needs. Generally speaking, although for various reasons these aren't hard and fast rules, for powders with the same rate of cure, a longer pellet flow indicates lower melt viscosity, which could result in the coating being more smooth, having less texture, and potentially a higher gloss. A shorter pellet flow is indicative of higher melt viscosity that may have more texture or result in increased coverage over sharp edges. For these reasons, an inclined plate flow test is a great way to confirm consistency between batches of the same coating, as well as to infer performance differences between a series of coatings that have a variable.
Doobie boobity boo.
A look in the lab.